Hello, math fans. Today we're going to talk about section 4.4, and this deals with the area between two curves. And there's some preliminary stuff. We're not going to talk about all that. We're going to just jump in on page 428, and we're going to look at, whoops there, 428. And we're going to look at example here, 3. So the area between bound by two curves is basically what we want to do is find the area. Sometimes they'll give us the bounds and sometimes they won't. Let's take a look at this problem right here. Here we have two functions. Function of x equals 2x plus 1, and g of x equals, what is it, x squared plus 1. So if we were to graph these, and I'm not going to go to a lot of detail graphing them, let's just draw a quick sketch. And this would be 1 unit and 2 units, and get just kind of a general idea. The straight line, 2x plus 1, would go through the point 0, 1. It also goes through the point 2, 5. 1, 2, 3, 4, 5. 2, 5. Kind of comes through here like this. And this might be a little exaggeration, but it kind of gives us an idea. And then you have a curve that's coming down. This curve right here is a parabola, and it's coming down through here, and it's turning, and then it's coming back up through here. So maybe not a great looking curve. Let's flatten it out a little bit. So what we're trying to do is we're trying to find this area inside here. Pretty cool, huh? So it's the area bounded by two curves. Now on this one, we can kind of see that on the x-axis it's from 0 to 2, huh? But sometimes we don't know the boundaries, so we have to calculate them. So let me show you how to calculate the boundaries if they want the bounds of the entire curve. Sometimes we just want to find what are the what's the boundaries of the curve from 0 to 1, you know. So they might put a restriction on the boundaries, but on this one there's no restriction. So maybe you didn't know where the bounds are. You're going, well, where's the boundaries? Take the two functions and set them equal to each other. And then just solve that problem. Set them equal to 0. Solve the problem for 0, just like you would any other quadratic, and that'll give you the boundaries. So let's bring over this 2x. And let's bring over the 1. And so we have x squared minus 2x equals 0. And then all we have to do is solve that. We're going to factor out an x. X minus 2 equals 0. And then solve that. Take each part, set it equal to 0. Obvious one answer is 0. X minus 2 is 0. X is 2. And we got our bounds, 0, 2. And we knew our boundaries by looking here. But if we didn't know the boundaries, just take the two equations, set them equal. The other thing is, maybe we don't know which one. Like we can see, obviously, this is the uppermost bound and this is the lower bound. But maybe we, don't have a graph, or we don't want to take time to graph it. We can still find that pretty easy. It doesn't really matter which one you go with first. If you go with the wrong one first, when you get through with your final answer, it's going to come out negative. Change it to positive because you can't have a negative curve, and you'll be fine. Okay. If you put the wrong one as the upper bounds. In fact, I'm going to do this problem wrong on purpose. I'm going to take, so to do this, I'm going to take the integral, and I'm going to put the wrong one on top. I know that the upper bounds is really 2x plus 1, but I'm going to put x squared plus 1 on the top minus 2x plus 1 on the bottom. So I'm going to subtract the two equations, okay? And of course, this would be dx. Okay, so then I'm going to work that out. I'm going to expand that out and see what I got. This would be x squared minus 2x minus 0. So this is going to be x squared minus 2x dx when I simplify. You can go through that a little bit. Okay, so now I'm going to take the integration of that. That would be x to the third over 3 minus 2x to the second. I don't know what that's doing there. Over 2 from, and what are my boundaries? I should have put the bounds in here in the first place. They should have been 2 to 0, and it's still 2 to 0, and it's still 2 to 0. And this little mark, I don't know how it got in there. It's not even supposed to be in there. Let's get rid of that. See if I can erase that out of here. I don't know what that's doing. Okay, so I got my boundaries. I got my graph. I'm all ready to go. Going to substitute a 2 in here. I've got a 2 to the third over 3 minus 2. I'm going to put a 2 in here, 2 to the second over 2 minus 0 to the third over 3 minus 2 times 0 squared over 3. Well, this right in here is going to give me 0. 0 cubed over 3 is 0. 0 squared over 3 is 0 times 2 is 0. So this basically zeroes out. Okay, so now I have, I've got, let's see, what do I have here? I've got 8/3 minus 4 times 2 is 8, and 8 divided by 2 is 4. So if I cross multiply, Chris, cross, applesauce, I get 8 minus 12 over 3. See, so I ended up with a negative 4/3, and I did this on purpose because I put the wrong one on top. And see how I got negative 4/3, and it should have been positive 4/3. That's easy to correct. Okay, now it's positive, and there's my answer. So pretty easy to do. You know, you just got to stay with it. Okay, let's try another one. We're not going to spend too much time going over examples. I thought I had another one here someplace. I lost it. Here's one. I'm going to use a smaller pen. Bring this down just a little bit. Okay, that doesn't look too bad, huh? So here's the graph. And this, the upper bound would be kind of a smooth graph. So that's this graph right here. And that's y equals 40 minus x squared. That's my upper bounds. We call that the upper. Okay, and then this kind of jaggedy curve here is given by a kind of confusing curve, y equals x to the fourth minus 3x cubed minus 4x squared plus 10. Got to be careful having that come down. Now, on this particular one, you can see the boundaries. Let's see, we got something here. There it is. There we go. The boundaries would almost be -2 to maybe 4, huh? A little over 4 if we wanted to do the entire curve. But they want to restrict it to just this boundary right here from 1 to 2. Okay, they just want to find the area under the curve that's bounded by these two curves. I should say the area bounded by those two curves in just this thing. So they're going to give us the boundaries on this one. The bounds are 1 to 3. Okay, so they didn't want the whole thing. They just wanted just this specific area to be calculated. Okay, So if you didn't know which one was on top and which one was on the bottom, you'd still be able to solve it. It would just give you a negative answer. If you did it wrong, if you did it correct, you're going to come out with a positive answer. You can kind of see a smooth curve like this is probably the easier one is on the top, and then the more jagged one is on the bottom. But if you're not sure, it'll work. Okay, so let's set up our integral. Integral is going to be from 1 to 3, 3 to 1, 1 to 3. Let's call it 1 to 3. It's going to be 40 minus x squared minus the quantity. And let's right there, I made a little mistake. I want to correct it right away so it doesn't look so bad. The square should be inside the parentheses. It's not this whole thing squared, so we want to make sure we don't cause confusion that way. Okay, minus, and then I'm just going to write the other one. What is that one? It's going to be x to the fourth minus 3x to the third minus 4x to the second plus 10, and then this whole thing. Okay. So obviously we're going to have to distribute that out. We're going to have to multiply this by a -1, get rid of this parentheses, and then simplify all those terms inside. So not waste a lot of time on that one. Let me go ahead and just simplify it out. I have worked this out before. So, you would distribute your minus sign to all these and collect like terms and all that. And we can simplify it down to negative x to the fourth. And I'm going to put them in descending order also. Plus 3x cubed plus 3x squared plus 30. And all that would be dx. So now I want to take the integral of this thing, and the integration of this would be, or the antiderivative is negative x to the fifth over 5 plus 3 times x to the fourth over 4 plus 3 times x to the third over 3, and we can see those are going to cancel, plus 30x from 1 to 3. Okay, so now we're going to replace, and this unfortunately is not a 0, so we're going to have to calculate that. So we're going to put a 3 in all these, and this is where the math, what you need to have is a good calculator to help you out on this baby. Okay, so we got, I'm going to just write it down real quick here. We have negative 3 to the fifth over 5 plus 3 to the third raised to the fourth over 4 plus 3 cubed plus 30 times 3. And that's all the positives. Now we're going to do the minus the other side. So all this take away, and I'm running out of room here. Let's see if I can squeeze this in. This will be a negative 1 to the fifth over 5 plus 3 times 1 to the fourth over 4 plus 1 to the third plus 30 times 1. Maybe put that. Okay. So what I did here is well, let's go ahead and just distribute this. This would be negative 243 over 5 plus 243 over 4 plus 27 plus 90 plus, and I'm going to go ahead and distribute the minus sign right away. So this is going to end up plus 1/5. This is going to become a minus 3/4. This is going to become a minus 1, and this will be a minus 30. And you can see it gets a little messy. Now I'm going to combine all the like terms together. And when I combine all the like terms together, I end up with something that looks like this. Negative 242 to the 5th plus 240 to the 4th. So I just brought this over to this. And then I combined all the like terms, all the numbers. You got 2790 minus 1 minus 30. I think that gives me... I didn't quite calculate that out. 686, I believe, plus 86. So now I use my calculator to kind of finish it out. And this is going to give me negative 48.4 plus 60 plus 86. And if I calculate all that correctly, I should come up with 97.6. So a lot of manipulation with numbers here. And that gives us the area inside here, which is pretty exciting. And whatever it is, maybe these were meters or whatever, we can find, and of course, this would be square, whatever it is. So that would be pretty exciting. And they got, you can try some more of these. The other thing we want to look at is one other kind of problem, and that's called the average value. The average value. And there's a special formula for this. It's on page 431. The average value is y average is equal to the bounds, 1 over the upper bound minus the lower bound of the integral. And of course, this would be a is the lower bound, b is the upper bound of some function of x dx. So we're going to try this problem in the book, example 6, pretty easy one. We want to find the average value of function of x equals x squared on the interval, and it's going to be 0 to 2. So it's a matter of just kind of putting it into this formula. It's going to be 1 over 2 minus 0, upper bound, or the bigger number minus the small number. You can think of it that way. And this will be 0 to 2, the integral of 0 to 2 of x squared dx. Okay, just that easy. And then we're going to just calculate that out. So this comes out to 1/2 on the outside times the integral of this, which would be x to the 3rd over 3, the integration from 2 to 0. So basically we have x to the 3rd, so this would be 2 to the 3rd power over 6, 2 times 3, minus 0 to the 3rd over 6, the upper bound. So we don't really need this. This is going to come out to 0. So it looks like it's going to be 8/6 would be our answer. Or we could reduce that to 4/3 or 1 1/3. And there we have our answer. Try to reduce these, if you can. So it's pretty easy to find the average boundary. They can do it on harder problems and so on. In example 7, you can kind of work through it. You kind of see if your boundaries are on number 7. I'm not going to work through this whole problem, but the boundaries on this one are 5 to 25. So this would be 1 over 25 minus 5. See, it's the boundaries. And then you put in your function, this one being a rather complicated one. So this is going to take a little time to do because they've got a kind of a messy little problem here. It looks like you put a restriction on t that has to be less than or equal to 30, but we're not going to worry about that right now. So this would be basically what you'd have to integrate and put the first step in, and then you can simplify it 1 to 20, and then we would take the derivatives of these, and this would be times this whole thing, huh? So this is t to the fourth over 4. This would be negative, huh? And 4 times 200 would be 800. This would be t to the third over 3. So this would be 3 times t to the third over 3 times 20 would be 60. Plus this would be t squared over 2. So this would be 3t squared over 16, 2 times 8. Plus this would be 60, don't forget to put the t, from 5 to 25. And there you got it. Okay, and then you would simplify all this down, and you can see this is one gigantic mess, and they worked it out in the book, and they got 68 3/4 for the answer, or 68.75, you know. So you can see sometimes these equations get kind of messy to work with, but you just got to take your time. So work on these, and they shouldn't be super hard. You're getting pretty good at this step.